In 5th grade and subclaim C, things change a little bit. Whereas in 3rd and 4th grade, we focused on the properties of operations. In 5th grade, we're really going to be looking at place value as our main focus area. Oh, I'm sorry, I missed a page. In addition to properties of operations, so I'm sorry, I misspoke. So we do still have this in 5th grade, this focus on properties of operations. But we also have then an additional reasoning focus area in 5th grade of understanding place value. Particularly using place value as a strategy to solve problems, understanding the logical progression of place value, and so on and so forth. So as you look at 3rd, 4th, and 5th grade subclaim C, you'll see a lot of similarities, but you'll see that clear distinction with the 5th grade focus on the place value. And as we get to 5th grade, we really should be, and as you look at the content standards in particular, we really should be solidifying the student's understanding of place value, because that's going to then be extended into the other, as they go in the rational number system, that place value structure is going to be built upon. An important thing to note is that the children also need to be able to think about a logical process when they approach a problem and they approach a solution. And you'll see on this slide in particular, I need to think about, maybe I have a logical process, but it's incomplete. Whereas when I'm not meeting the standard, my process is incomplete or illogical. Okay. So as you think about the reasoning, and that's where these mathematical practices really come to bear, you want to see have opportunities on a regular basis for students to express their reasoning, so that then you as a teacher can assess whether or not that's developing. All right, now subclaim D, again, you will see extreme commonalities from 3rd, 4th, and 5th grade. Subclaim D across the board focuses on modeling, and it focuses on the solution of real-world problems. So what they're going to do is they're going to take that content in subclaims A and B. They're going to use the reasoning in subclaim C to then create this modeling kind of scenario and assess for modeling in subclaim D. Now, I want to point out a couple things. You're going to have students regularly engage in the modeling practice to prepare for this. And what you're also going to see down here in this kind of end of this description of what subclaim D is, these are all the standards for mathematical practice. So if you don't do the standards for mathematical practice, your children will not have a prayer for being successful with subclaim D. And what will be beneficial with the PARCC assessments is you'll actually get that information back. So maybe you'll have some students who aren't as proficient with some of the procedural aspects of the mathematics. Maybe they have a minor calculation error, but you'll be able to get feedback on how well they can do some of these mathematical practices. Now, some of you may be saying, well, they can't do subclaim D without A, B, and C. You do not have to be perfect at A, B, and C to be successful in D. And some of the sample items that I've looked at from PARCC, you'll look in the rubrics and they'll see that if you can take a flawed computation, for instance, but use that computation correctly in the course of solving the problem, then you will still be credited, I guess you would say, for some of the subclaim D accountability. So that's something important to think about in your grading practices, as well as how you encourage students to participate. If they have the wrong answer, you need to dig in and figure out why that may be. So let's look at subclaim D for each grade level. Again, I'll make reference on the left-hand side, this 3D1 comes from that blueprint document. So as you look at subclaim D, as you should with subclaim C, is you want to have the blueprint document and this performance level descriptor alongside. As I look across subclaim D for grades 3, 4, and 5, you will see again, as with C, that there is a real similarity across all the content area, or all the grade levels rather. And so subclaim D is just modeling. And what's interesting is, as the PARCC developers were creating these documents and talking about sample items and talking about what would be on the assessments, they felt so strongly that modeling was so important, because one could also argue that modeling could be put under reasoning. But they felt strongly that modeling was so important that it should be its own subclaim, because that's where mathematics comes to life. And so as you look here across the relationships that students are going to be using and illustrating and mapping and analyzing, this is where the level of sophistication comes into play. For instance, identifying important quantities. I may be able to need to do that, but that's not going to help me really achieve at the level I need to. Where that changes up is that then to actually meet the standard, I have to illustrate the relationships by using the provided tools to create models. So it's not just identifying what's important, but then what does that important information, what do those important quantities tell me about the mathematical relationship I'm looking at? Then you see with level 4, then I'm mapping that relationship to create models. And then to get to that level 5 distinguished command, I'm analyzing my relationships, creating constraints, creating goals, you know, what good is the model, those kind of ideas. So what's important to look at when you go across here is, first of all, this is a growth process for students. So you may have to start with the level 2 stuff if your children have not had a lot of experience with modeling, but you also want to gradually move into that level 4 and 5 stuff, so that when they get to the end of the school year, they have had a robust experience with modeling. Now, subclaim D with grade level 4, as I mentioned before, is you are having the same kind of increase in sophistication that you have in grade 3, and then again for grade 5. So what's important to do then is to take a look at what you're doing with modeling in each grade level, as well as, am I giving kids the opportunity to move from level 2 to level 3 and 4 and 5. And maybe at the beginning of the school year, especially in modeling, that I don't have as much level 4 and 5 stuff that I can get to because my kids aren't ready for it. But I eventually need to start to incorporate those kind of things throughout the grade level. And certainly as kids come to you in the next couple of years and they've had Common Core before, and this modeling process before in particular, hopefully they'll be more successful. All right, one more subclaim. And this is a subclaim that has not appeared before in state testing perhaps. And this is for grades 3 through 6. Of course, in this webinar, we'll be talking about what the fluency requirements are for grades 3, 4, and 5 in this webinar. But in this subclaim, this is the opportunity for students to demonstrate how well they are demonstrating fluency in understanding the content. Now, here's what's interesting. Let's take a look at this and you'll see. This is not just about a timed element, but it's also about applying kind of strategies. So here are the fluency requirements for 3rd grade, and they're pretty specific. Now, I would not go through and create a set of time tests that use this table. What I would do is look at how I'm treating, in particular, multiplication in 3rd grade, and whether or not I feel like my students are getting to a level of accuracy, and also whether or not they're becoming flexible in thinking. Now, there's important things to note here. There is a fluency requirement on addition and subtraction. There is a fluency requirement that involves using properties and strategies. There is a fluency requirement that involves a level of accuracy and also efficiency, if you want to say time is an efficiency. And then in third grade, we're also having a fluency requirement for multiplication and division that involves strategies and also involves memory. And so the idea that you know, we need to just do time tests ad nauseum is kind of incomplete. You may want to have a timed element every once in a while to see if students are developing that efficiency. But the way to build this is not in doing what these subclaims say. The way to build this is in starting the process of, number one, having students monitor their own fluency development and not be public. This is not a race, and it's not that I'm a better multiplier or adder or subtractor than you. But it's this idea that I'm setting goals for myself, and as my goals get more accurate and precise and efficient, then I move up these performance levels. So it's a valuing of not only the fluency in terms of kind of, you know, quickness, but it's also in using those strategies. And you see, the strategies don't go away. Just because I'm at a level 5 doesn't mean I stop using the strategies. It's just that I'm maybe better at them.